Hey there, tech enthusiasts. Welcome back to VL Podcasts by Visual Learners. Here we bring deep tutorials on machine learning, and on VL Extras, you'll find bite-sized insights into the latest tech trends. If you're new here, check out my portfolio and connect with me for updates on all things AI and tech. Today, we're diving into a fascinating story of a company that's blurring the line between fiction and reality. Could we be stepping into a real-life Westworld? So, Clone Robotics is a startup that just unveiled a groundbreaking creation, aptly named Torso. It's a robot with stunningly lifelike movement and strength, drawing comparisons to the host drones in the HBO show Westworld. Remember that eerie sci-fi series where human-like robots serve as hosts in a futuristic theme park? In Westworld, these hosts look and act so much like humans that it's hard to tell them apart. And guess what? Clone Robotics seems to be building their own version. Clone Robotics was launched in 2021 by Dhanush, Radhakrishnan, and Łukasz Koźlik, and they're based in Poland. Their mission? To build synthetic human-like androids capable of interacting and performing tasks with both strength and finesse. Their latest creation, Torso, moves like a human with the help of hydraulic muscles and an ingenious valve system housed in its ribcage. This bimanual torso design has lifelike shoulders, elbows, and even a neck, allowing it to move with human-like precision. Clone's CEO Dhanush said, "This is only the beginning. We're on the path to creating androids that'll blow people's minds. Soon you might see these androids doing everything from heavy lifting to handling delicate objects, tasks that require both strength and dexterity." It's ambitious but backed by innovation, including a hand design with an astonishing 27 degrees of freedom. Compare that to Tesla's Optimus, which has about 22. Okay, now I will hand you over to the actual hosts of the podcast.
Okay, get this picture, a robot hand. But not the clunky metal ones you usually see.
Mm-hmm.
This one is so realistic you can actually see the muscles moving under the skin.
Oh.
It's pretty wild. That's what Clone Robotics is building, and today we're going to take a deep dive into all the tech that makes it work.
Yeah.
We've got this article from New Atlas that breaks down how they do it. It's pretty mind-blowing stuff.
Oh, yeah. They're really pushing the limits of, biomimetic robotics, I think. It's not just about copying the look of a human hand. They're trying to recreate how complex it is and how well it, functions and all that.
Right. And before we get into all those little details, I'm curious, why do this at all? We've got robots now with those special grippers that can do crazy things.
Yeah.
Why would you go through all this trouble to build a hand that's so human-like? What's the point?
Yeah, that's the big question. And the answer is all about how our world is built for human hands. Everything, doorknobs, tools, even just delicate objects, they're all made for us to grab with our hands. So a robot with a human-like hand, well, it wouldn't need any special adaptations or anything. It could just interact with our world. And that could change everything, from manufacturing to healthcare even.
Oh, for sure. And it makes you think about how we'd interact with these robots too, right? A hand that looks more human, I don't know, it might make those robots seem less scary, more approachable.
Yeah. That's a whole other area of research, how robot design changes how we see them and interact with them.
Yeah.
But I think for now, let's stick with how Clone Robotics is actually making this thing.
Okay, deal. So first thing I noticed in this article, the hand has this see-through skin.
Oh, yeah.
You can see everything working inside, like the muscles contracting and relaxing. It's kind of freaky looking, but also super cool.
Yeah, it's definitely got that uncanny valley vibe going on. But for engineers, it's awesome to be able to actually see how everything works. It helps them, analyze and improve it so much better.
Right. So about those muscles, the article mentioned something called the McKibben muscle concept. Can you explain that?
Okay, so think about squeezing a tube of toothpaste. You push on the sides and the paste comes out the end, right? Well, a McKibben muscle is kind of similar. It's this mesh tube with a balloon inside. When the balloon expands, it squeezes the mesh, making it contract.
Okay, I think I'm getting it. Now, usually these McKibben muscles need external pumps to inflate those balloons. But Clone Robotics, they got rid of those pumps altogether, right?
They did. They had this really smart idea. They fill the balloon with this special fluid and then put a heating element right through it. So when you run electricity through it, the fluid boils and boom, instant muscle contraction. So each muscle has its own built-in power source.
The article even had this example using, acetaldehyde. They said just heating it up, 50 degrees Celsius makes the pressure jump over 6 times higher.
Yeah. It's amazing, but cooling it down to make the muscle relax, that's still tricky. I saw some videos where they're using a water spray to cool them down quickly. Shows how far they've come, but they've still got some work to do.
It's still pretty cutting edge, for sure. So we've got these crazy advanced muscles. What about the skeleton? How did they design that part?
Well, they basically made a perfect copy of a human skeleton, molded bones, hinges, the whole deal. They really focused on getting that natural range of motion we have. The article said the hand has like 27 degrees of freedom.
Wait, 27? That's insane. So it can move almost as much as our own hands.
Exactly. And get this, they even managed to copy the way the wrist and thumb move.
Right.
Which is really important if you want something that's good at handling stuff.
Oh, yeah.
It's not just about the bones either. They copied the whole network of muscles and tendons that go through the forearm and hand too, all working together, just like a real hand.
It's like they rebuilt the entire anatomy of the hand from scratch. It must be incredibly complex to design and control a system like that.
Oh, it is. It takes a ton of knowledge about human anatomy and advanced robotics to even get close. And we haven't even touched on the hydraulic system that powers it all yet. That's another engineering marvel on its own.
Okay, let's get into that then. Is it like those giant systems they have on construction equipment, just like shrunk down?
Not quite.
Yeah.
It's super advanced, but yeah, it's way smaller. Imagine like a network of tiny little tubes and valves, all controlling the flow of fluid to each muscle. And in the middle of it all, there's this powerful water pump that creates the pressure for those contractions.
Water? Seriously? Why not use oil like they do in most hydraulics? Wouldn't that be more efficient?
That's a good question. But remember how those artificial muscles work? They contract when the fluid heats up, right? Water, it can absorb a lot of heat before its temperature changes much. It's got a high specific heat capacity. I think that's what they call it.
So using water is actually better because it can take more heat, which means stronger contractions?
Yeah, exactly. And don't forget, water is easy to get, it's not toxic, and it's way cheaper than most hydraulic fluids. It's a win-win situation, really.
Okay, that makes sense. And how do they make sure all these tiny parts move perfectly? Didn't they say they used magnetic sensors for that?
Yep. Those sensors tell the system, the angle of each joint and how fast they're moving in real time, so it can adjust and fine-tune things as it goes. It's like giving the hand a nervous system.
So it's not just about building a hand that looks human, it's about giving it the ability to actually sense and react like one too. That's what makes clone robotics so different, isn't it?
Absolutely. They're not just trying to copy the form, they're trying to capture the intelligence of a human hand. And that's where things get really interesting.
I'll say. And speaking of interesting, the article said clone robotics isn't stopping with just the hand. They're working on a whole torso too, with a rigid spine, no less.
Yeah. That's super ambitious, but it shows how big their vision is. Their goal isn't just a hand, it's a whole humanoid robot that can exist in our world. And the torso is the next step.
So what's the deal with the torso? Didn't they say it was going to have like over 120 muscles or something crazy like that?
Yeah, 124 to be exact. They're talking about recreating all the muscles in the neck, shoulders, arms, chest, upper back, everything. And it's all going to be powered by their artificial muscle tech.
Whoa! Just picturing all those muscles and tendons all working in sync. It's mind-blowing.
It is. And it makes you wonder, why choose a rigid spine? Why not a flexible one, more like ours?
Yeah, that's true. Wouldn't a flexible spine let it move more like a human?
You'd think so. But this system is already so complex, all those moving parts, all that control. A rigid spine, well, maybe it gives the whole thing more stability, especially for the arms and hands.
That makes sense. Kind of like building a house, right? You need a strong foundation before you start adding walls and stuff. The rigid spine is like the foundation for the whole upper body.
Perfect analogy. And it shows how important it is to build things in stages with a project this big. Making a whole humanoid robot, that's a crazy goal. So they're breaking it down, making sure each part works perfectly before moving on.
So first the hand, then the torso, then maybe legs, a full skeleton eventually.
Exactly. They're focused on the upper body now, but I wouldn't be surprised if they started working on how it moves around next. The article mentioned the torso would be on a locomotion platform. That sounds like they're already thinking about it.
That's wild. So they're taking this step-by-step approach to building a whole robot. But honestly, it's all so complex. How big is their team? It must take hundreds of engineers to do this.
You might be surprised to hear this, but Clone Robotics is still pretty small.
Really? Wow. The stuff they're doing, it seems like it would take a massive company.
I know. It seems more like a startup.
Oh,
A small group of super talented people all working together.
that's pretty awesome. It shows you don't need a huge corporation to make groundbreaking stuff happen. Just dedicated people with the right skills and passion, I guess.
Definitely. And that's what Clone Robotics is all about. They're not just building a robot, they're changing what's possible. And they're doing it with so much creativity, it's really inspiring.
It makes you wonder what else is out there waiting to be discovered, you know? If a small team can do this, what else is possible?
It's a great question. And I think it's something we should keep in mind as we explore, the world of robotics and how it might change our future.
Yeah, totally. So we've talked about the why, the how, even the who behind this tech. But now I think we got to ask, what's next? How could this technology actually be used, and how might it change things?
Now, that's a question that takes us into some pretty interesting, even transformative territory.
Right.
I think it's time to dive in. So we've talked about why they're building a human-like hand and all the cool tech that makes it possible. Now, I think we should zoom in on some of the design choices they made.
Yeah.
Like, what do they tell us about how Clone Robotics thinks about this stuff?
Okay, yeah. Like that water-based hydraulic system. I'm still kind of stuck on that. Using water just seems so, I don't know, unusual. But then when you think about how those muscles work, it's like, oh, duh, that's actually brilliant.
Yeah. It's like simple, but also cutting edge at the same time.
Yeah.
They could have gone with regular oil, like everyone else, but they went back to nature for inspiration. Like how our own bodies use fluids to move.
Interesting. And it's not just about being like eco-friendly, although that's definitely a good thing.
Right.
It's more about how they made those muscles so efficient and controllable.
Exactly. Water can absorb so much heat before it gets hotter,
Yeah,
That means the muscles can contract harder and you've got more control over them.
that makes sense.
They've really optimized the whole system for like performance and sustainability all at once.
It's some outside-the-box thinking, for sure. And what about those sensors, those magnetic sensors they use for feedback?
Oh, yeah.
Why magnetic? Why not like optical sensors or something else?
Well, think about it. Inside that hand, it's pretty chaotic. All these parts moving, fluids sloshing around. Magnetic sensors, they're tough.
Okay.
They don't care about dirt or light, even water doesn't bother them. So they're perfect for getting accurate readings, even when things are, messy.
So it's all about choosing the right tool for the job. Even down to the type of sensor, it shows how much attention they paid to every little detail, making sure the system's tough and reliable.
Oh, totally. And those sensors, they're the reason that hand can sense and react to what it touches.
Oh, right.
It's how they get it to make those tiny adjustments that make it so good at handling things.
So it's like they gave the hand a sense of touch.
Yeah, pretty much. It can feel what it's doing and adjust its grip or how it moves, just like we do.
That's insane.
That feedback loop is what makes it possible to control things in a really, human-like way.
So we've looked at some of their design choices, and it's clear they put a lot of thought into every single part, but they're not stopping there, are they? What about that full torso they're building?
Oh yeah, that's a big leap forward.
Yeah.
It shows just how ambitious they are. Remember, their goal isn't just a hand. It's a whole humanoid robot, one that can really be part of our world.
Right.
The torso is just the next step on that path.
Okay, remind me what's so special about this torso. It's going to have like over 120 muscles, right?
That's right, 124 to be exact. They're planning to recreate every muscle in the neck, shoulders, arms, chest, upper back, the whole thing.
Yeah.
And all powered by those artificial muscles they developed.
Whoa, it's hard to even picture that. All those muscles working together, moving smoothly. That's crazy.
I know. And it makes you wonder, why a rigid spine? Why not make it flexible? More like a human spine.
Yeah, that's a good point. I would think a flexible spine would give it a wider range of motion.
Yeah. But remember, this system is super complex already, right?
Yeah.
So many moving parts, all that delicate control stuff.
Right.
Maybe a rigid spine. It just makes the whole thing more stable, especially for the arms and hands.
Makes sense. Kind of like building a house. You got to have a strong foundation before you can put up the walls.
Exactly. The rigid spine is like the foundation for the whole upper body.
Love that analogy. It really highlights how they're taking a step-by-step approach to building this whole robot. It's like they're mastering each stage before moving on. So first the hand, then the torso, and who knows, maybe legs next.
Right. They're focused on the upper body now, but who knows what the future holds. The article did mention that this torso will be attached to a locomotion platform, so it sounds like they're already thinking about how to make it move around.
That's wild. So they're building this whole robot piece by piece, but honestly, The level of detail is just mind-boggling. How big is their team? It must take hundreds of engineers to pull this off.
You might be surprised to hear this, but Clone Robotics is still a pretty small company.
Really? I mean, the stuff they're doing, it seems like it would take a massive company to pull this off.
I know, right? But it seems like they're more like a startup, just a small, tight-knit group of brilliant minds working towards a shared goal.
That's amazing. It just goes to show that you don't need a giant corporation to make groundbreaking advancements. Sometimes all you need is a small group of dedicated people with the right skills, passion, and a bit of daring, I guess.
Absolutely. And that's exactly what Clone Robotics embodies. They're not just building a robot, they're pushing the boundaries of what's possible, and they're doing it with a level of creativity and ingenuity that's just, truly inspiring.
It really makes you wonder, what else is out there waiting to be discovered? If a small team can achieve this, what other incredible breakthroughs are just around the corner?
That's a great question, and one that I think we should keep in mind as we continue exploring the world of robotics and, all the potential it has to change our lives.
Absolutely. Okay, so we've talked about the why, the how, and the who behind this incredible technology, but now I think it's time to shift gears and talk about the what next? How could this technology be used in the real world, and what kind of impact could it have?
Now, that's a question that takes us into some fascinating territory, some really potentially transformative stuff.
Yeah.
I think it's time to dive in.
Okay, so we've talked about why they built this amazing hand and all the tech behind it. We've even gotten a sneak peek at their plans for a whole torso.
Yeah.
But now I think it's time to think bigger. Like, how could this tech actually change the world?
It's pretty mind-blowing when you think about it. A hand this real, this capable, the possibilities are kind of endless.
Yeah, for sure. And the article mentions a few ideas, like prosthetics.
Oh, yeah.
Imagine a prosthetic hand that doesn't just look real, but it actually works like one too, with the same dexterity and everything.
It would be life-changing for so many people. Think about all those everyday things we take for granted, like writing or cooking or even playing music. A hand like this could give people those abilities back, help them live more independently.
And it goes beyond just like replacing lost function, right? This tech could also enhance what humans can already do.
Yeah. Like imagine a surgeon operating with a robotic hand that's super steady and never gets tired. Or a technician doing really delicate work with superhuman precision. It could revolutionize fields like medicine, manufacturing, even research.
That kind of precision and control would be invaluable, that's for sure. And don't forget about like hazardous environments. A robot with this hand could handle dangerous materials or work in disaster zones.
Right.
It could save lives.
Exactly. And what about space exploration? Astronauts, they struggle to do even simple tasks with those bulky gloves they have to wear. A robotic hand could be a game changer up there. Let them handle tools and stuff with incredible precision.
Wow. So we've got prosthetics, surgery, manufacturing, hazardous environments, space. The list goes on and on.
It definitely doesn't stop there. Think about entertainment, even. Imagine animatronics that move and, express themselves just like real people.
Yeah.
It would create these incredibly immersive experiences, unlike anything we've seen before.
My mind is officially blown. It feels like we're on the verge of this robotic revolution, and this hand could be leading the way.
It's an exciting time to be alive, that's for sure. But with all this potential, I think it's important to think about the other side of the coin,
Oh, yeah, for sure.
What are the challenges, the ethical questions that come with this tech?
Right. We can't just get caught up in the cool factor and forget about those things.
Exactly. Like, what about jobs? If robots can do the work humans do now, what happens to those people? How do we make sure this tech creates new opportunities instead of taking jobs away?
That's a big one. We need to be ready for those changes, invest in education and training so people can adapt.
Totally agree. And then there's the potential for misuse. A hand this advanced, well, it could be used for all sorts of things.
Right.
Some good, some not so good. We need to have ethical guidelines and rules in place to make sure it's developed and used responsibly.
It's like any powerful tool, really. It can be used for good or bad. We got to be smart about it.
For sure. And what about how it affects us socially and psychologically? As robots become more human-like, how will that change how we see them, how we interact with them? Will we start treating them differently? Will it even change what it means to be human?
Those are big questions, and I don't think there are easy answers. But we definitely need to be asking them as this tech keeps developing.
Absolutely. It's a conversation that needs to involve everyone. Scientists, engineers, policymakers, even the public. We need to work together to make sure robotics benefits everyone.
So as we wrap up this deep dive into clone robotics, I'm kind of left with this feeling of awe, but also, I don't know, a little bit of cautious optimism. The tech is incredible. It really could change everything.
I'm with you there. We're seeing a huge shift in robotics right now. It's up to us to make sure it's used for good.
Yeah, it's a big responsibility. But for now, I think we can just appreciate how creative and innovative this is. Clone robotics is pushing boundaries, showing what's possible when people set their minds to something big.
It's a reminder that there's so much potential out there. It's up to us to use it wisely and responsibly. And who knows what amazing discoveries are waiting for us just around the corner.
That's the best part, isn't it? There's always something new to explore. And thanks to pioneers like Clone Robotics, the future of robotics is looking pretty bright. Thanks for joining us for this deep dive. It's been a blast exploring this with you.
Yeah, thanks for having me.